Hi, welcome back to the channel. Okay, so let's look at functions of several variables. We look at another example. Okay, so from the tutorial sheet that I showed in the previous video, you can check out the link of that video in the description. This question that we are about to do is question 8. Okay, so let me just counter check to see if it's actually question 8. So let me see. Oh yeah, it's question 8. So I've skipped a lot of questions. Yeah, so you don't have to worry. I'm going to get back to each of them. I just couldn't resist the fact that this question is pretty interesting. Yeah, so let's look at it. So this question says if z is equals to f of xy, where x is equals to t plus s and y is equals to t minus s, you have to show that this mixed partial that you have here is equals to the second partial with respect to x, second partial with respect to y there, where our z is of course our main function, kind of. Okay, so for simplicity purposes, I can actually name this as my a, then that as my b. Okay, so I can choose to show that a is equals to b. Okay, or I can choose to show that b is equals to a. I'm still going to end up with the same result, but just going to show that a is equals to b. You can try out the other way around; it's still going to work out for you. Okay, so we are simply using the chain rule here. Just in case you're not familiar with such examples, I'm going to leave another link in the description that has a playlist of some videos that I did some time back. It does a lot of such examples that require proving and the like. You are dealing with partials, and yeah, they're pretty interesting examples. You can try to look at them. Okay, so since I'm showing to say my left hand side is equals to my right hand side, I'm obviously dealing with partial of z with respect to t. Someone might ask to say, why am I talking about partial of z with respect to t instead of partial of z with respect to s? It's simply because I'm just going to bring in the s when I look for the the second, kind of like the second derivative in this case, like the second partial. This is a mixed partial, so I'll bring in the partial with respect to s afterwards. Okay, so my partial of z with respect to t is simply equals to my partial of z itself with respect to x multiplied by partial of x with respect to t plus partial of z with respect to y multiplied by partial of y with respect to t. Okay, so this is what I have right here for now. I'm not going to disturb this for now. I'm going to leave it there like that. I'm going to do the substitution a bit later, and you see the substitution I'm talking about. Okay, so let's go ahead and find the second mixed partial, which is this one that we have right here. So the way this is going to be is that our mixed partial, we're going to say second partial here is our mixed partial. You have your partial of t there, partial of s. This is just going to be equals to um, partial with respect to s. That's how this one has come in now. Remember to say I use t. Now I've brought in the what? The s. That's what you have right there. I've brought it now. So this now we just have to you're looking for the partial with respect to x of partial of z with respect to what? With respect to t. But we already have our partial of z with respect to t. So we say partial with respect to s. What is partial of z with respect to t? We have already written it's this one here. So let's just bring it down here. This is partial of z with respect to x multiplied by partial of x with respect to t plus partial of z with respect to y by partial of y with respect to t. Okay, so this is where now it requires us to do to think a bit critical. Okay, we are dealing with the chain rule. We have to bring in the product rule and the like. Okay, so how this one is going to be, I'm just going to write it, then I'm going to explain how everything has come about. Whatever that I'm going to write, I'm going to explain. Okay, so you can actually write these as individual partial derivatives, where this one alone, then again you write this one alone. Okay, so the way this one is going to be is that if you had to use the product rule on this part, okay, this is going to be the second partial of z, okay, with respect to with respect to with respect to x, okay, multiplied by, I still have this part, multiplied by uh, partial of x with respect to s, okay, with respect to x. Now I actually think I've made a mistake uh, to leave this one out. Okay, to leave this one out. Why am I thinking I've made a mistake? It's simply because this is going to be too long, but anyway, it's fine, it's okay. I'm just going to say multiply by the same, which is my partial of x with respect to t. But let me not waste your time, I think, because I'm actually wasting time and space. This one here is you can get it from here. Okay, it's a 1, because if you get the partial of x of this with respect to t, you're going to get a 1. So let me not actually bother to put it. Okay, so I can leave it. Then I'll say plus. Then here I'm going to have second partial. This is a mixed partial. Then you have partial of x, partial of y here, and this is multiplied by partial of y with respect to s. Okay, remember we have this s here, so that's where I'm getting this s and that s there. Okay, then what I've gotten right here, this is for this one. Let me go ahead and write for that one there. Okay, so here we say plus, then observe to say this is just going to be the second partial with respect to we have our y there. I'm writing x, that's supposed to be our y. Then we say plus, and we are going to have another mixed partial. We say that with respect to, you have your y and your x there, then multiplied by I think I've forgotten something. Okay, so here I'm supposed to multiply it by partial of y with respect to s. Here I said partial of x, okay, with respect to s. Then I said partial of y with respect to s. Now it's like it's the other way around. Okay, so then you say plus. That's when now we can bring in the mixed partial, the second mixed partial. There we have partial of y with respect to x, now multiplied by, you observe to say here I used partial of y, meaning on this other side this is going to be partial of x with respect to s, like that. Okay, so now let me explain what everything here means. So this one here, you have to keep in mind to say that comes in to say this x that you have here is changing with respect to s. Even if you think of it in terms of y, this y is also changing with respect to what? With respect to x. That's why we have that. Then under this kind of like, it's looking complicated, this mixed partial that we have here, you have to keep in mind to say this is just it's a mixed derivative which represents the change in the rate of f. In this case, your f is what? It's just more like your z. Okay, it represents the rate of change in the z with respect to x. For example, here is with respect to x as what? As y is changing, this y that you have here. So it simply means to say even this one is with respect to y as x is changing. I've just simply gotten it from here. Okay, I'm hoping it's making sense. Okay, so this is what we end up with. So let me just try to rewrite it on top here a bit properly. Okay, so here we said we have and maybe before I even do that, I can simplify some certain things here. So if you look at this one, this one, this one, and this one, I think we have them here. So that's partial of s with respect to x. So partial of x with respect to s is equals to 1. You treat this as a constant, you differentiate this one, you get a 1. Then what about partial of y with respect to s? So partial of y with respect to s is equals to negative 1. So you get negative 1 there. Okay, then you can bring it right here. So what we have is we say partial of, that's the second partial with respect to x multiplied by, here we observe to say partial of x with respect to x, sorry, partial of x with respect to s is a 1, so I don't have to put anything there. So I'll put 2 there, then plus. So here partial of um, here you have your partial of y with respect to x. What do you get? You get negative 1. So you get negative 1 there, so meaning this one is a minus. We have a mixed partial like that, then we say plus. So for this one, uh, here partial of y with respect to x is a negative, so this is also going to be a negative. Say negative. Second partial there with respect to y. Then for this one, this is going to be positive. Okay, that would be plus, because partial of x with respect to x, partial of x with respect to s is a 1. So you're just going to have the second partial there, then you have your y and your x. So in this case, what we have here, you're able to observe to say these two are going to cancel out, these mixed partials, this and that are going to cancel out. They are going to be the same. I know this is different, but in this case, dealing with such a question, they're still going to give you one and the same thing. Actually, there are some questions where you're required to prove that that's still going to give you the same thing. Okay, I think that's under the plus. Okay, so what this tells you is that what you have here, it has resulted due to having a second partial there with respect to x squared minus second partial there with respect to y, like that. So you observe to say this is equals to, this is equals to that, and we can say hence shown. And that's how we answer this question. So don't forget to like this video, and in case of anything you need some clarity, you can drop it down in the comment section. Thank you very much for watching, and we'll catch you in the next video.